Hi everyone! Today we're going to be doing an American tour lesson, and our lesson is about Old Faithful's next eruption. Our learning target for today is I can use tables, graphs, and rules to understand rates. So we'll get to the ideas of today's lesson in just a moment, but first I want to make sure that everybody understands what we're talking about. First of all, Old Faithful is what's called a geyser. So what that basically means is that it's a space, and it's in Yellowstone Park, where water will come up from below the Earth's surface. And when that happens, we call it erupting, kind of like a volcano erupts. Old Faithful is called Old Faithful because it's pretty simple to predict when it will next erupt. And that's what we'll be working on in class. We'll be working on figuring out when Old Faithful will erupt based on how long the eruption was. That's a rate. So remember that a rate is a comparison between two unlike quantities, like miles per hour, or price per ounce, or minutes per day, things like that, when we have two different quantities and want to compare them. So that you kind of know what it looks like. So in just a moment, you're going to see what it looks like when Old Faithful erupts. Right there is just some steam coming out of the geyser hole. There it goes. Okay, so what happens then is you can use the length of the eruption to figure out how long you'll have to wait until the next time that Old Faithful erupts. So how it works is like this. You have a waiting time, we'll call that W, and that equals 10 times the length of the eruption plus about 30 minutes. Now, it's not quite that simple. It used to be very, very close to that, but now some earthquakes and other activity in the area has actually made those times be just disrupted a little bit. So usually park rangers will add a couple minutes on. But let's say that the eruption was 2 minutes long. So we would say 10 times 2 plus 30 minutes. So I can put that into a table, and then that's the length of the eruption was 2 minutes. So 10 times 2 is 20 plus 30 minutes. That would make our wait time about 50 minutes. If the length of the eruption was 3 minutes, we could multiply 10 times 3, which would be 30, and add 30 minutes. So our wait time would be approximately 60 minutes. So you can see that this is the application of a slightly more complicated rule or formula as it's used in real life. Tomorrow in class, we'll practice using the formula and we will plot it into a graph. Here's your quiz question for tonight. Based on the formula given, which was 10 times E, or the length of the eruption in minutes, plus 30, how long would you have to wait for Old Faithful to erupt if it just had a 5-minute eruption? Thanks for watching and have a great night.